Hello, everybody. We're going to be working on Chapter 9 today. I am substituting today for Christian's class, and I'm kind of excited to be teaching a chapter I don't normally teach to my Java classes, but I'm glad that Christian is ambitious and is getting you guys to do this stuff. We are going to learn about a few important things in the Java language here. First of all, we're going to be looking at sorts, and really what's kind of interesting here is we're going to learn about two types of sorts that typically, I don't see this type of material until you get to like a second or third level programming class where you start talking about sort algorithms, but they're really kind of showing you the base level of it. You're not really necessarily writing it from scratch in a sense. In a way you are, but in a way you aren't. But these are two pretty simple things that we can do. Normally you learn about sorting algorithms when you take a data structures class, and I know, Brenda, you've been probably down that road before, where you learn how to write these things on a nitty-gritty level. Instead of using methods that do the work for you, you actually do it manually. We're going to learn about two-dimensional and multi-dimensional arrays. That's a pretty important construct in programming. And then we're going to learn a little bit about the array list and some of the methods that come with arrays when you use them as a class. And also this concept of enumeration, which is really kind of a way of saying creating your own custom data type of array. That's the best way I can really describe it. And an enumeration is really, if you think about this, if you're enumerating something, what are you really doing? You're numbering it. Right? And you're putting it into a structure and numbering it. So if I take a class of people and line them up, class of students and line them up, and I put them in order, I've basically enumerated them. It's kind of a way to think of it. And sometimes it's best when you have a simple analogy like that too, when you're learning some of these concepts. And so sometimes I kind of revert to those kind of like pictorial images, I think, because I think they help. All right, let's talk about this concept of sorting, and this is where they start the chapter, which is really kind of an interesting place to start a chapter like this. But you guys, conceptually, you get what a sort is, I would think, right? So for example, if I go back to the analogy of a classroom full of people, and I line you guys all up, and I say, okay, everybody, get up out of your chairs, stand all in a line, right? So you kind of would randomly form the line. You might stand next to your friends, perhaps, or you may decide, well, this is really close to where I was sitting, so I'm going to just sit right there, or stand right there, that type of thing. There's no real necessary order to what you're doing. But if I were to say to you, and this is kind of one of those things that happens when you're in grade school in particular, right? They'll say, okay, line up alphabetically, right? And then hopefully they already sat you alphabetically, so it's really easy. You just take your rows of the class and just put yourself out there. Or the other good one is by height, right? Like shortest first or tallest first. And then that's really, for me, visually, that's a really good explanation of how a sort works. Because if you randomly got into a line with a group of people, how would you know how to order yourselves? Well, of course, the tallest person in the room and the shortest one are usually pretty easy to spot, right? Especially the tallest one, because everybody's got to look up to them. And then you get the people who stand on their toes and try to see who's actually taller. But there's an algorithm that you use, right? So you kind of look at the situation, and you just look at one other person and you go, well, I'm taller than you, so you go that way and I go this way. And you know what? That's basically how most sorts work. Not by collectively ordering everything automatically, because really there is no automatic sorting, right? Everything has to be looked at. It's just a matter of what your step-by-step approach is. So if you want to make the comparison over to the Python class, like where you guys are also taking that class, it's one of those like stepwise refinement things that they were talking about in one of the chapters we were reading, where you really need to break it down into little pieces. And using a real world example, I think, is where it really strikes home, because that, like looking at the other person and saying you're taller, I'm shorter, that automatically makes you think about it. And really what you're doing is you're creating an equation, right? if shorter, you stand over there. If taller, you stand over there, right? Or really, it's really answering one question, not two. So what they give here as an example is, how do you actually order something? Well, here's a problem, right? If you're going to switch values, so what they have here is a value A and a value B. So they say value A is 16 and value B is 2. All right? So which comes first numerically? Well, clearly 2 does, right? That's the smaller number, so that if you were sorting from smallest to biggest, you would put 2 first. But how do you adjust the order of things inside of an already existing structure? That's really the issue. So the only way to really do it is you can't directly change the values of 2 variables or 2 positions in an array. That's what we're going to be doing. You have to have a temporary placeholder, which is what they're showing here. So they take one of the values, put it in temporary storage, put the correct value in the first position, and then take the temporary storage and put it in the second position. So really what you need is a third placeholder to make the swap. So a really simple sort algorithm would be something like what you see here. So you do some sort of a conditional test where you ask the question, is something bigger than the other? And if it is, then you need to make the adjustment to get the things into the right order if they're not in the right order. See, the problem with that little if statement is we're trying to go like in counting order, right? We start at 1 and go up to 100, for example. Well, if A is greater than B, then A is in the wrong spot, so we have to move it. See the logic there? So B is actually smaller and it should go first. So that's the little algorithm that we use to kind of switch that. Now here's where we start to talk about some actual sorting terminology, and this is, one for really computer scientists, honestly, because if you guys go on and like further your career path by going to a 4-year institution, and I'm going to tell you what, anybody listening to this video or sitting in the classroom or listening online, you guys should, right? If you just want to get working, get this 2-year degree or a 1-year degree and get working, great. But whoever you end up working for, see if they'll pay for you to go to a 4-year. They probably will, because they value IT people. And if not, you should take the initiative to do it yourself, because that's where you really kind of ramp things up. And when you get to that point, typically you're going to be studying computer science on the collegiate level, which is kind of a little bit different animal than just programming. It goes a little bit deeper, but you cover a lot of these kind of hypothetical things. You also learn a lot about these sort algorithms when you start venturing into the database world as well, because they do a lot of sorting and ordering and cleaning of data and preparing data for presentation. So this is where, really sorts kind of come from. All right, so they have this thing called the bubble sort, and just kind of read in that paragraph there, see where they have it highlighted. It says, in the bubble sort algorithm, you continue to compare pairs of items, swapping them if they are out of order. So the smallest items bubble to the top, right? And I remember when I was first taught this concept, we were taught with different data structures in doing it. So we're going to be using an array structure to do this, and that's typically what we use. But I always hear the analogies that kind of stick in my head of like stacks of dishes. Like, you guys ever go to like a buffet and you have a stack of dishes and they're like a spring-loaded mechanism, right? And that's kind of an interesting example of an array that's last in, first out, right? And that's not exactly what we're dealing with here, but sometimes you're dealing with structures that are kind of contained like that. So the point of that is, if you were sorting the dishes from smallest to largest, you want the smallest ones to bubble up to the top. But how do you do that? You can only compare 2 at a time. So you can only look at 2 items in the structure at any one time to make adjustments. So as you go through the structure, it's necessary sometimes to kind of go through the structure maybe even a few times to get it properly sorted. Some sort algorithms are actually more efficient than others. I wouldn't call bubble sort necessarily the most efficient of algorithms, but it does work. although it can be resource intensive when you get to very, very large data sets, and that's something to consider as to why you use one sort algorithm over another. All right, so let's take a look at their example here. It says, to use a bubble sort, you place the original unsorted values in an array such as what's listed there. So you got an array of ints declared called sumnums. You got 83, 33, 99, 22, and 54. And so then they start to walk through the algorithm verbally, right? So the first thing you're going to do is you're going to compare the first two. So is 88 greater than 33? Yeah, so if the first one's greater than the second, what do? We swap using the algorithm we saw before. So now it's 3388, right, if you want to think of it that way. Then we move to the second pair, all right? The second pair is now 88, I can go this way now, right? 88, 99. Backwards for you guys, right, if you're looking at my hands. Which is bigger? Wait, they're already in the right order, right? Don't have to swap a thing, because 88 is not bigger than 99. Move on to the next pair. Is 22 greater than 99? No, right? So you got to swap, right? And notice how that, at that point, now you have 33, 88, 22, 99, 54. And then you go on to the next pair and highlight those, and of course those have to be swapped. But then you end up with this list. The list becomes 33, 88, 22, 54, and 99. Some of the values have moved over, but not all of them. So how do you kind of fix that, right? So it says, when you reach the bottom of the list, numbers are not in ascending order, but the largest number, 99, has moved to the bottom of the list, which is a good thing, right? So really all we did is, because 99 was near the beginning of the list, or a little farther over, we did manage to move that one over. We managed to move 88 over, but 88 is still kind of an issue, right? So they give you some sample code here. So for example, in order to do a sort, because you're traversing an array, and you guys have probably learned this already, this is one of the reasons we have looping structures, is so that we can traverse structures like arrays. And this is the algorithm so far. So I want you to just take a really quick look at that. So it says we have B, so whatever B is just our index value for the array, all right? And we're going to keep running through this array until we get to whatever the length is minus 1. Remember, array position start at 0, so if I have 5 or 6 numbers, whatever it was in the array, I have to subtract 1 from the length in order for it to match the array number. That's why we're doing that. So then we start doing that check, the same one that we did. So if we look at whatever is in position B, right, and that's the first position. Is the first position greater than the second position? And the second position here, we're doing it dynamically, right? We're not hard-coding the numbers. We're letting the loop generate that for us. So we're always going to look at pairs, right? So the first and the second, and then we'll kind of go through there. That's why the +1. And then we just use the algorithm that we have, just transposed over to these two values. So there's no real magic there, but that's what we're doing so far. The problem is this, that even though we went through the algorithm, it's still not sorted. So this is one of the classic problems of computer science. That's kind of funny. So in order to sort it, now you have to do it again, right? Same algorithm, but notice the first time we did it, right, here we got 4 bullets full of stuff. Well, we got 4 bullets again. Why do we have 4 bullets? Because we have 5 numbers. There's four comparisons we're making. So for each pair, 1 pair, 2 pairs, 3 pairs, etc. So we run through it again, and then we end up moving everything into the right position after the second attempt. So after the second attempt, the order is correct. So it takes 2 passes to make it work, right? Or am I wrong? Yeah, I am wrong, aren't I? Right? 33 is still bigger than 22. So now what? Yeah, guess what? We have to do it again. All right. So here's the interesting part of this. You know, if you look at what we've done so far, we've now taken a loop inside of a loop. So we've looped twice to make this work. All right. So now a clever person might say this, okay, and this is just a different way of thinking, mind you. A clever person might say this, that what if I just write one loop, right, and just call it multiple times then? Okay, put it into a method and call it as a method. True. But what if every time I iterate through the array, I also iterate again for each position, putting the loop inside the loop? So it says to fully sort the worst case list, one in which the original numbers are descending as out of order as it could possibly be, you need to go through the list 4 times, making comparisons at swaps. At most, you always need to pass through the list as many times as is the length minus 1, right? So once again, kind of matching up with the array position. So this is kind of an interesting conundrum. So, and why this sort algorithm is not necessarily the most efficient one, but that's what you need to do. So somebody took the time to study this to the point where, regardless of the length of your array, how many times must you run through it in order to get it basically the whole length of the array minus 1? That's just the answer to it. So that's why we put the loop inside the loop to make it happen. All right. So the interesting thing is that you could also keep track of this whole thing. So in other words, you could actually preset your array. And I don't know that I would necessarily approach it this way, but what they're giving you as an example is, instead of putting this little tidbit in here, right, the length of the array minus 1, what they're doing is they're presetting a variable to that value and then feeding that variable in here to the table. Now, why this is efficient is simply because you're doing the checking outside of it, and it gives you a way to kind of keep track of it at the same time. Do you have to do it this way? Absolutely not. But notice that the one difference here is that you're nesting it one layer deeper and adding an if statement in the middle to do the check. It's not really functionally that much different. All right. The other thing that you can do is you can also sort arrays of objects, and this is where it gets a little bit weird. All right. When we're just dealing with numbers or even alphabetizing strings, it's a little bit easier to kind of wrap your head around. But in this case, they're giving a different example where they have a class of employee created here. So we have, all the earmarks of, constructible class, right? So we have private variables up at the top with their employee number, last, first name, salary, etc. We have a constructor in there and gets and sets for all the fields, right? Those are all the methods. So really all we're defining are the properties of this entity called employee. So we could create an array of employees, right, of size 5, call it sum employees. And then we could we could create a method called the bubble sort. You can name it that way if you wish. And you can feed into it an employee array. Isn't that kind of interesting that you can actually pass arrays as objects from method to method? You can absolutely do that. So what this would do is it would preset a couple of variables. First thing it does is it declares A and B. It's not initializing them, just declaring them, so reserving the memory space. It also creates a temporary version of the employee object that's coming in. And we're just giving it the name of temp. And what is the reason we're doing that? to not alter the original structure just in case, right? We're just passing it in as is, and then we're going to go ahead and do the sorting. So then we go ahead and we use the latter technique that we saw where we are setting the array length to a variable, and then we're setting up our nested loops. Same basic approach, except because we are presetting that array length -1, we're using that name in place of it, but structure-wise it's exactly the same. Now notice that, what are they sorting here, actually? What thing are they actually sorting? They're not sorting by like last name, are they? What are they sorting by? Salary. And it's really interesting, I think, because that is sortable for sure, right? Like who's making the least, who's making the most, that's an easy thing to do. And what they're really doing here is, are they sorting the salary from lowest paid to highest paid, or the other way around? They are going lowest to highest, right? And really the tip to that is, if the first array position is bigger, yeah, that's what we're doing. So same exact methodology that we had before, and they're using that same approach. So here's what I'd like to do now, is I'd like to walk through the you-do-its. We'll build this, and I know Christian probably wouldn't do it this way, but this is the way I do it when I teach my Java classes. I like to walk through the you-do-its. In fact, in many of my Java classes, I assign these as assignments. And yes, I know the code is given, but sometimes people still struggle getting it to work. But I'm assuming you guys will do great with this. So I'm going to go ahead and bring Eclipse up on my screen. And just want to make sure my font is big enough for you guys to read. Is that big enough for you guys to read? You guys good with that? Right. And if you're, interestingly, if you're curious about what Java 2 looks like, here's a Java 2 assignment up on the screen right now. Just so you know. I'm going to close that though. Because I'm like fresh working on this, I'm going to create a new Java project, just so I can create a new folder here. I'm just going to call it Chapter 9. And that just creates a new, root here on the left-hand side. And then I'm just, I don't know how Christian teaches you to do this stuff, but I'll show you the techniques I use in Java. I'm just going to go ahead and right-click that now and just say New Class. And, I know that this book has the weird thing where they tell you what to name it at the end. So I'm going to call it Bubble Sort Demo. That's my thing here. So Bubble Sort Demo, no spaces or anything like that. I'm going to click the little checkbox here to create the public static void main, which you guys have memorized already, right? The other thing I sometimes point out, and you guys haven't been in class with me for Java before, so the package declaration, folks, is useful if you're creating a lot of programs. Many times what I usually advise students to do is just forget it, just delete it, doesn't really matter, because we're just doing a one of. I'm okay with you guys leaving it in, so whatever you want to do is fine. All right, go ahead and click Create, and then usually my first step is I blow away the comments. And I'm sure Christian probably does the same thing. It's kind of like I almost do it intuitively. All right, but let's go ahead and start pasting in the code that they want us to use. So they want us to pull in this utility here. Let's just manually add it. Now, you guys have probably learned as soon as you need a utility, like if you're typing code and you need it, Eclipse will actually prompt you by underlining the item in red, and then you can add it in with a control space key combo. I don't know if you guys are aware of that or not, but I assume you probably do know that. Notice that they're creating just a straight class file here. Notice that they're missing the public aspect of it. Does that matter? Frankly, no, it doesn't. In fact, if you omit the public in front of class, public is implied. just so you guys know that. All right. So, and then we do have step one basically complete. All right. Let's go ahead and move on to the next thing. So they want us to declare an integer array, and then check the length of that array -1, put it in a variable, add the scanner, and then prompt to get these items. So let's grab all 4 of those lines and drop them in. All this stuff is going to go inside the main method, by the way, like so. So an array of integers, a variable preset to the length of the array -1. We got the scanner in place so that we can input stuff, and pre-initializing some variables. And I don't want to say pre-initializing because that's not correct. We're really just declaring them at this point. Initializing them would actually be the act of putting a value inside of them, right? So just to kind of like reinforce that concept of like what does Eclipse do, and I don't know if you guys are taught this or not, so I don't mean to be weird about it, but like whenever you see like you put in a command like this that's calling out an external class from the Java libraries, when you're at the end of the keyword, all you have to do is control space, and then it just drops the import in automatically. Did you guys see that happen? Right, and I don't know if you know that or not, but if you do, well, great. That's a pretty important little trick, and one of the reasons why we use IDEs, because it finds the right library. Sometimes you have to be careful with that, though. My one little word of caution is this. Sometimes there are classes inside libraries that share the same names, but they're different libraries, so you have to be careful. Like when you get into GUI programming, for example, you guys might learn a little bit in this class with little swing components, but in Java 2 we predominantly use Java FX, and those require different libraries, and sometimes you control space and you get a list of libraries. You got to be careful which one you choose, because they're not all created equal. This one, fortunately, is part of like the core Java library, so not a problem at all. Right, next thing that we're going to do is we're going to create this loop, and in this case we are actually going to prompt the user to enter the values for the array. So instead of having a pre-created array with values already in it, we're going to ask the user to type them in. Okay, not really that big of a deal. So enter a number, and then what they do is they will take that, and notice how we're initializing this loop here. We start at 0, and really what we're trying to do is correspond to the array positions. Okay. And then notice also that in the system out statement, they're going enter number whatever. So how many values are you going to type in here? The answer is already on the screen. Right? How big is the array we created? 5. When will this loop stop? When we reach that last position, right? Which is position 4, 5 minus 1. That's how that will operate. So, all right. So we'll keep asking the user to do that. Next thing to do, it's not a bad idea once you get stuff from a user, is to actually go ahead and display that stuff on the screen so they can see what they've entered, right? Well, here's a situation now where we're calling upon a method that we don't have on the screen yet, so my anticipation is the author is going to ask us to create that method. All right. Next, call a method that accepts the array and sorts, okay, which is 0. So what we're going to do they ask us to, actually, yeah, they do that much later. So I'm going to tell you what, in my brain, I wouldn't leave that step to chance, and it seems like to me, they're kind of working top down, but my thought right off the bat is I would create this first, right? So that's how I would proceed. And an easy way to do that in Eclipse is you just hover over the item. Notice how it brings up the little box here. It says, the method display, blah, 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 is undefined. One quick fix available. Create the method. Hey, you know what? Sounds good. Right? Why would I want to type code if it can do it for me? And in fact, it gets pretty intelligent and starts guessing at some of the stuff. I'm just going to leave that alone now, and I'll come back and fill it in later to what the author expects us to put in there. But I want you guys to like be encouraged to use the automatic tools, especially when you do your own coding, so that you get into more of that accelerated workflow. That's why we use IDEs, is just to help with things like this. It could be that the way that the statement was created isn't up to spec with the author, but you know what? We can easily change it from public to private, if you think it even matters. We can easily change the arguments that we're throwing in there. Not a problem at all. All right, so for right now, let's just do that. The next thing is to add a loop that shows, or that actually, excuse me, does the actual sorting. Now this is the same loop structure that we were using in the examples that the author was giving above. So I'm going to do a little bit of indenting here, just for clarity's sake. And what I like about sometimes like just doing this manually, I know there's automatic tools that do it, and that's not the point here, is it forces me to kind of look at what I'm doing. So I want you to kind of look at the arrays. You see how they're nested. Yes, they could be condensed down a little bit. But we have the same two loops. We're running the same algorithm that we were running before, trying to get them smallest to largest. But notice at the conclusion of each outer loop, we are displaying the values to show you where it's at, and then decrementing that little counter that we're using for the inner loop. And I think that's pretty important that you see that little tidbit. The display part, I think, is really useful too, because when you run it, as it loops through, you can see through each iteration how the bubble sort is actually working. I think it's pretty fascinating to see that as a result, so I think that's a really good addition by the author to do that. All right, let's go ahead now and put in the code for the display method. And if you notice, nothing really too tricky here, but he does have it set to public static void, right? Because we're just displaying stuff. And he's got an int array and a regular int as variables coming in. Let's see how that matches with what Eclipse did. Not too far off, right? Now, how did it, let me ask you this, how did it know to put in an int array and an int as parameters to pass? How did it know to do that? Well, it's pretty easy because we declared them here, right? We were throwing an int array at it and an int. So it's like, well, if you're throwing an int array and an int, I better receive those on the far end, right? So that's the why. Now they named it A in the book, but I here. So guess what we need to do? We need to change that to an A or change the A to an I. One or the other has to happen. Additionally, if you look at the example, right, you know, one of these lines is part of the for loop and one is not. So the first one is part of the for loop, so I'm going to indent it. You don't have to do that, by the way. But you guys should have learned by this point, whenever you have like an if statement or a for loop or something like that, and you only have one statement, you don't need the curly brackets. But you know what my advice to students always is? Throw them in anyhow. Because you know what happens is then you start to forget what's part of the loop, especially if it's not indented properly like that. So the output of the display thing is going to talk, is first going to put on the screen which iteration we're on. So it's going to display which time we're going through, okay? And then on top of it, it's actually going to output the actual numbers and some space. Looks like a single space in between. That will help us do the sort. All right, let's go ahead. I believe we're at the end. Yep, we are. let's go ahead and save this. All right, and do a run. And get the console up on the screen here. All right, and I'm going to actually just pull this up a little ways. I'll leave the sorting algorithm in the background here. And we know we have to enter 5 numbers. All right, so let's just put in some numbers. All right, I have to make sure that I put them out of order a little bit. Right? Are they out of order? And I haven't pressed enter the last time because I know when I press it again, it's going to do the sort. So let's take a look at what it did. So lists out all the iterations, right? So the first time through, we went from 2, 4, 6, 4, 1. So the first time through it did what? It just displayed it because that's what we told it to do, right, before we went into the sort. Then here, it looks like it moved the 4 over and the 6 way over. That's good. The second iteration through, the 1 got moved forward. And notice really, you know, if you look at the pattern here, you notice how the 1 keeps moving 1 forward each time? And this is really kind of the problem, and why I intentionally put 1 last, is to show you this effect. Because whatever's in the last position, if it happens to be smallest, that's why we have so many iterations we have to go through to get it to the top. There's no other way to get it to happen. But that is called bubbling to the top, although our structure is sitting sideways, but if you could turn it this way and look at it, you would see that progression. All right, you guys all good with that one? All right. All right, let's talk about another type of sort now. And this one is called an insertion sort. So let's just look at the comparison. It says, for example, it says, when you use an insertion sort, you look at each list element one at a time. All right, well, right, so instead of comparing 2 at a time, looking at 1 at a time, that's kind of a little bit of a mind bender. It says, if an element is out of order relative to any of the items earlier in the list, you move each earlier item down 1 position and then insert the tested element. This is a different algorithm, all right? The bubble sort is where you, going back to the example of the kids standing in line, shortest to tallest, is going by pairs through the whole list over and over again until you get the right people in the right order. But you have to look at each pair as you go through. This is kind of a little bit of a shortcut approach. So for example, if I'm standing in a group of like 5 people, I can instantly identify, oh my God, you are tallest or you are shortest, front of the line, right? Isn't that what you would normally do? And you think about that in that capacity, that's exactly what you would do. And if you really get into sorting theory, so this is actually like one of those computer science things. There's other ways to do sort. So for example, if you were in a room of, let's say, 30 people, and you're trying to sort shortest to tallest, and you say short people over here, tall people over there, people who are like 6 foot plus will automatically walk to the one side of the room, and the 5 foot tall people will go to the other side of the room kind of automatically. So we're kind of grouping them themselves in essence, and that's kind of another technique, and it goes to like a higher level sort. But let's look at their example. It says, if a list contains the values 2, 3, 1, and 4, you want to place them in ascending order using an insertion sort. You test the values 2 and 3, but you do not move them because they're in order, right? However, when you test the third value in the list, 1, you move both 2 and 3 to later positions and insert 1 at the first position. This is more like that approach. It's like you're only 5 foot tall, front of the line. I mean, that's kind of the technique here. Now the question is, logically, that's not a problem for my brain to think about, code-wise is a different thing, right? So like, how do we get that logic into code? The bubble sort is a really easy one because you're always comparing two, and even though you have to go through it a bunch of times, you're still always comparing two. This is a little bit different. All right, so let's take a look at their example. First, they start with an integer array, 90, 85, 65, 95, 75. All right, clearly out of order. I mean, I can visually spot the smallest right off the bat, right? Like, as I'm sure you guys can. And in this case, they're using a while loop. Notice that they're presetting our loop control variable, or sentinel value, if you want to call it that, to an A, or to 1. Okay, so we're going to start counting at 1. All right. And then we're going to, instead of going from 0 to length minus 1, you guys see the technique here? We're going from position 1 to whatever the length of the array is, which in this case is 5. So we're going 1 to 5. We're still counting 5 times. All right. First thing we do is we take the first number, so the first number in the array, and we put it into a temporary value. Okay. It's right off the bat. Second thing we do is we set a variable called b, and that's going to take the value of a minus 1, which puts it at 0 to start with, okay? And then we run a secondary loop. So we're presetting the loop so it can run. So if b is greater than or equal to 0, which it is, and a number in the array in position b, or 90, is greater than the temp, what's temp going to be to start with? 85. Right? So as long as this value is greater than 85 and b is greater than or equal to 0, so we've got that combo happening, we're going to go ahead and do this. So the first thing we're going to do is we're going to take that next value, so b plus 1, b was where? 0. Now we're adding 1, so position 1, so whatever's in position 1 is going to be whatever b is. And which one was that? A. Switching them. See the technique? It's just a different type of logic. And then we're going to decrement b. Okay, so where's b at right now? Where was b when we started? What's a minus 1? 0. Right? We're going to decrement b. b then becomes less than 0, minus 1. So this loop won't run again. But watch what happens here, and this is kind of the fun part. I think it's fun. Some nums, b is at minus 1. We add 1 to it, and it becomes 0, right? So the first position of the array becomes whatever the temporary value was, which was 85. Right? So if you start to do a trace of this, like you could do stops or whatever in the program and follow it, we just actually move the numbers here, right? The next step would be that we increment a, and by incrementing a, we're then reaffecting b, so we're going to move through the array now and keep going. All right, that's kind of the point here. All right, so if you want to follow the logic, you keep going and you keep going to get it to happen. All right, so the point that they're making is, which we just figured out, is after these steps, all we managed to do was to move 85 and 90 and basically flip them. Now, it says the outer loop becomes a 2, and then the logic proceeds. So the value of temp becomes 65, right? And then at some point, if you start following through this, we end up finding the value that is smaller, which is 65, and then that gets dropped into position 0 directly without having to do a secondary comparison to get it there. That's really kind of the shortcut in this loop. All right. So you basically keep looping and doing comparisons. But the beauty of this loop is this, that it dynamically adjusts the amount of times it needs to run based on how out of order it is. It's kind of clever, I think, you know. And of course the author's got a video on it. Have you guys ever watched the author's videos? Okay. They're pretty good, actually. All right. Let's actually try this out and do this next you do it. Before we do that, let's take a 5-minute pause. So you guys good with that? All right, back from break, and we're going to do this you do it. All right, so they have some instructions here to open up the thing that we were just working on and change the class name and save the file as. And I don't know if you guys go through that process just like they recommend. And, you know, that is one way to do it. So they want us to call it Insertion Sort Demo. So we'll just do a save as. All right. Next step is remove the declaration for comparisons to make. So they want us to just get rid of that. It's not part of the logic of this program. Remove the 14 lines of code that constitute the nested loops that perform the bubble sort. In other words, remove all lines from the start of the second for loop to the closing curly brace following the statement that decrements. All right. So my reading of that indicates to get rid of this section of for loops. I don't know if that's 14 lines of code. Looks pretty close, right? So, sayonara. See you later. So apparently we're still going to be prompting the user to enter the numbers. Okay, so that's fine. Replace the removed lines with the statements that perform the insertion sort. These are statements that you saw, et cetera, with the addition of a display method. All right, so we're just going to take this code here and drop it in. You know, the other thing I sometimes recommend with something like this is if you're forgetting what you're doing, I mean, if you name your stuff right, you shouldn't be forgetting. But you can always throw comments in, too, to kind of help clarify what this little block of code is doing. So you could just, you know, throw in your, you know, whatever here. This is the sort algorithm, if you wish. If you were doing coding professionally, I would say that's almost mandatory, just so that you don't come back at some later point in time and go, what the hell was I doing here? Frankly. All right, so we're just going with the stuff that they gave us here. All right, and then simple as that, let's save it and give it a try. All right, so let's go ahead and give it a run. And let's bring up the console so we can actually see it. And I'm going to move it way up there. I assume we're entering the same number of numbers. Now this is a little bit more interesting. Now the bubble sort, keep this, yeah, this is, you know, because with the bubble sort, remember what happened with that one? The 1, which is in the last position, got moved each time. Here, what's happening is we're going one value at a time and moving it if necessary. So first we're checking to see, is this are these in the right order? They are. Are these in the right order? They are. Are these in the right order? No, they weren't. You know, remember where we were starting from. Then we take the smallest value and just put it right where it's supposed to go. And then we're checking the last position, and then that just gets bumped right up to the front. Now notice, it took the same number of iterations here. didn't it? Right? Because ultimately we still have to go through all the values. Now the question really becomes, like, if you were working with larger and larger array structures, which would be more efficient? There is an answer to that, and the answer is not what you might think it would be. What's your guess? That's my gut feeling on it too. It turns out I think they're both equally inefficient, or as efficient as each other, because you still have to end up going through still have to check all the positions. Yeah. So one way or another, you're not really saving necessarily any time on that. But algorithmically, this one seems a little bit more elegant because it tends to operate more the way our brains operate, as opposed to like this methodical pair by pair approach. But either way, you're still getting it done. So, all right, let's go back over to the chapter. You guys need to remind me, when does this class end? 2:50? Okay. All right, now let's move up to a little bit more advanced structure, and for me, probably one of the more important, concepts in this chapter is really this two-dimensional array thing. So when you guys learn to do the arrays, just arrays themselves, you have discovered pretty quickly that it's a named construct. It's really a variable that holds multiple values. It's probably the best way to look at it. That's how I think of it. There's one name, and then you can access all the parts of the array by using the index values of the positions. Right? But what happens if you set up an array of arrays? This is what we're talking about. So from a conceptual standpoint, an array, I think of, and I often do this when I teach arrays, and here I am switching back to Eclipse, but really what I mean to do is bring up an Excel spreadsheet. And the reason I do this is to kind of really demonstrate, kind of like the structure of an array. So for example, when I think of an array, I'm just going to start typing values in here. And that's probably big enough. And what I'm going to do here is, I'm doing a little bit of formatting just to kind of like demonstrate a point. So these are the index values, right? And then these would be the actual values that would sit here. So when I think of an array, I think of the structure. And notice that, even though we have really only 6 positions here to put information, all of them share the same name, right? So for me, it really helped me a lot when I first learned this concept to kind of visualize it kind of in this fashion. So whatever value I would happen to put in here, whether it's like a number, or if it was, a string, whatever it is, it's associated to the main variable by virtue of the index, okay? But that is, really, it's a single, it's a one-dimensional array because, and the reason we call it that is because it's linear, right? If we're going to add to this array, all we're going to do is make it longer. It's just going to keep going off to the right until we don't need it anymore. But if it helps you to kind of visualize an array in this fashion, then please do so. Where it really becomes more helpful is this. An array, and this is where the book is going next, and I wanted to show that graphic first. We can actually work with what we call a two-dimensional array. And when we start to work with a two-dimensional array, really what we're creating is like what we see in the spreadsheet, where, if I just delete all this stuff here, or just Control-Z my way out of it all, right? Just get rid of it until it's all gone. And then I take a look here, that really one row of a table in a spreadsheet is like a single or a one-dimensional array, right? When I start to add rows, additional arrays, I now have an array of arrays, which also is equivalent to what, folks? A table in a spreadsheet. And really a two-dimensional array is the foundation of so many of our data structures. That's why this is an important concept and important to understand. But how would you declare a two-dimensional array? You would do it something like this. Notice that for each position in the table, you have two array index values. One indicates columns and one indicates rows. So when we work with a two-dimensional array, that's kind of like the process that we use. Notice that the top leftmost position starts with 0, 0. And then as we go across, the first 0 stays in place. So that tells you that the first value typically is associated with rows, and the second value is typically associated with columns. Is that actually how it works? Is it actually a table? Well, conceptually in our brains it is. All right? And when we get to multidimensional arrays, I'll explain why. Because we get to the point here where when we look at a two-dimensional array, we see it as a table, and that makes sense to us, right? Because you can see it flat on a piece of paper or in a book or on a screen. Easy to comprehend. How will you actually go ahead and declare that? It might be something like this. Not might be, it will be something like this. So instead of one set of square brackets, you use two, right? So that indicates an array of arrays. Give it a name, call the constructor function, and then we say int 3 and 4. Well, if the first one is rows and the second one is columns, we're creating a table with 3 rows and 4 columns, right? If you want to hard code or pre-hard code the values in to the array, you can do something like this. So what the author is doing here is, you guys know that you can declare an array by just using int square brackets and then throwing in a set of values, comma separated, inside a set of curly brackets. But if you're, doing an array literal like this, an array of arrays, those curly brackets still have to sit inside a master set of them. So each array is separated by a comma and inside a set of curly brackets. But by laying it out in this fashion visually on the screen as you're declaring it, really kind of helps you see it. And I would, and frankly, if I was coding this, I would actually probably move like this. I'd probably hit a space here, move it over so it lined up, and then you like visually are seeing it. And I know that a lot of coders, when they're working with like predefining an array very much in this fashion, they're really meticulous about like getting everything all lined up, because that way when they need to go back and look and troubleshoot, it's all lined up already, and they don't have to like decipher it. Because yes, you could put this all in one line, and it would still be just as valid. The reason we arrange it visually is for our sake, not for the software's sake. All right. So a lot of different things. When you start to work with a multi-dimensional array, really what it gives you is this capability of working with organized data, right? So this is why this is powerful. So in this example here, they're talking about how they have this structure, and the first column relates to which floor of the building they're on. How many of those have 0 bedrooms, how many have 1 bedroom, and how many have 2 bedrooms, depending on which floor, and then what the values are in each one of these columns is what the rent is, right? And I look at that and go, wow, if that was, obviously not today's rent prices, right? But yeah, well, maybe around here, these people are probably in California or something, and, who knows what their rents are out there. All right, so if you wanted to take the same information here and arrange it into a two-dimensional array, you can just simply take all the rent values and set them up as 4 separate arrays. And notice that we're not putting in the floor number. That's kind of interesting. Why? Yeah, that's the index value of each array in the array itself. So, I mean, if we were doing database design, we would have a different approach, right? But in terms of like the logical structure of an array, this works out because we can still achieve that floor based just simply on the index value for each one of these arrays. So, since each array in the array has a position, this is position 0, position 1, position 2, position 3, 4 total positions, right? All right. Let's take a really quick look here at this little sample program that they're putting together. And they start by pre-declaring the whole array. They set up a few variables to work with: entry, floor, and bedrooms. We're assuming entry is getting input from the user, which it is, and they're using the J-option pane thing to do it. And so what they want you to do is enter a floor number, then that gets stored as an integer instead of floor. Enter a number of bedrooms, that gets stored in the bedroom variable. And then it just goes ahead and it runs a little dialogue here, and it says the rent for a whatever number of bedrooms floor is this much. And what it does is it just simply takes the value, plugs it into the table, and finds it in the table. So how exactly does it do that? So if we are working with floor, for example, enter a floor number. So which floor do you want to be on? Ground floor, first floor? Can we assume that 0 is maybe the basement? Is that why the rent is so cheap, right? You're living underground, like in the catacombs or something? Yeah, apparently so. Apparently, like, the Laverne and Shirley apartment is really cheap, is what we're getting to. But that's pretty true in apartment buildings, though. The higher up you go, the higher the rent is. Although that's not where you want to be if the elevator fails, right? Or if the fire, or if there's a fire, right? But you get the view. All right. But then if you enter a floor number, we're assuming that 0 is a valid entry. So 0, 1, 2, 3, or 4. So that will pull up the floor and the bedrooms. And then all it's going to do, so let's say I put in a second floor with 2 bedrooms, I would go 0, 1, 2. How many bedrooms did I say? 2. Then I would just go over to the second column. So there's a 0, 1, 2. Is that how it works? Is that how they have it broken down? 0 bedrooms, 1, 2. So 2 bedrooms would be the last column. So it should pull up $740. That's what it should do. That's one that you could actually try out if you want. It just shows you how it works. All right. Are you guys comfortable with that? I mean, the two-dimensional array conceptually is not that hard, okay, frankly. Where it gets a little tricky is sometimes when you traverse the structures, because you're traversing both a row and a column. And for me, it helps a lot. If you're hard-coding the values, arrange them. If you're not hard-coding the values, you still might want to make a graphic of it. My go-to tool is I just jump to Excel. I jump to Excel, I just kind of lay it out so I can look at it, and even if I don't use that for anything, at least I have this like mental picture of what I'm doing. And for me, that it's just a helpful thing. All right. Now, the next little topic here is actually taking a two-dimensional array and passing it over to a method. So the way that you do that is not any different than passing a regular array, but you do have to add that data type in there. So when you're passing a two-dimensional array, yes, you have to say int square bracket, name of the array. You have to put both of those in there so it knows it's a two-dimensional array. All right. Whether it contains ints, doubles, or in the third example here where they're actually passing an employee class over. All right, so that you can actually pass a pre-created or a self-created object too. All right. Next little topic here is talking about the length of a field with a two-dimensional array. So this is, not that far off of what we were doing before, but they'll give you an example here, and I think it's probably better to look at it like this. All right. So same little table, same concept that we're working with, bedrooms, floors, and rents, right? In this case, just setting up floor and bedrooms, and then we're running 2 for loops. So what this is going to do is a little bit different. The goal of this is to actually output all the information to the screen. Now, it's not going to output it in a table, obviously, because we're not telling it to do that, right? But it is outputting all the possibilities. So what we're doing here is we're setting up 2 loops, one to traverse the floors and one to traverse the bedrooms. So for each floor value, we're just going through and outputting each rent, and then we're listing the floor numbers and the bedroom numbers. But what's kind of neat here is it shows you row 0, we're hitting all the positions. Row 1, we're hitting all the positions. Row 2, we're hitting all the positions. And just showing you that your loop is working correctly, partially. So I'm always a huge fan of putting more information on the screen than you need, because more often than not it comes in handy anyhow, rather than trying to figure it out in the aftermath. But this is essentially doing the same type of work as we were doing previously. We're just not prompting the user to pick a specific thing. We're actually displaying all of it. Could you take this and output it to a format that looked like a table? Sure, why not? It's just a matter of orchestrating your system out print lines, right? So that's just a whole separate issue, but that's kind of the point of that. There's also this concept when we're working with multidimensional arrays of something that we call a ragged array. All right, so this is a little strange. All right, so notice first that we are declaring something like this, right? If we are setting up an array of arrays, the two-dimensional array called sales, and then we're pre-declaring one of the values, but not all of the values. So notice that we're pre-declaring that we're going to have 4 rows, right? The first position relates to the row. And in the second one here, we are setting up each one of those rows to have a different amount of cells. So really, it's not going to be a square table. Some rows are going to have more than others, and that's why I couldn't pre-declare it here, right? Because if one row's got 12, one's got 18, one has 9, one has 11, there's no congruent number that I can put here. I can only put a number in this position if all of these would be the same. But this does give me a way to actually set up a table that does not have the same number of columns in each row. Now, the question is, why would you need to do that? Well, you'd have to have a scenario for where that's valid. I don't know what the scenario would be. In this case, they're trying to give an example of sales. Well, the reality is if you're a salesperson and you're selling stuff, some people sell more than others. Maybe that's kind of the thinking here. All right, let's move on to multidimensional arrays. And this is where I think it gets really fun, right? Because when we look at a table on the screen, it's flat. I see the rows, I see the columns. All right, not a big deal. But adding a third dimension to the array, and that's what they're doing next, right? So the example they're using is the rents for a building, a floor, and a number of bedrooms. So now we're going from one apartment building, right, to an apartment building complex where maybe one building in the complex is by the garbage dump or by the highway, right? And the other building's on Lakeside by the park, right? So they're 2 different buildings. And that we still have the floors and the bedrooms, but now we also have basically a selection of which building we're in. And maybe there's more than 2 buildings, maybe it's 10 buildings. And we don't like see that a lot around here, but if you ever travel to some larger cities, sometimes they have complexes that are like that. It's particularly public housing. But now you have basically 3 array structures nested. And I want you conceptually to start to think about this. Because if we're working inside of Excel, right, and I have an array, and then I have an array of arrays, how do you visualize that third array? Because what we're saying is that each one of these array positions in this 2-dimensional array also contains another array. So really, there's a structure like this inside of each one of those cells in a 2-dimensional array. So from a visual standpoint, when we start to work with 3 dimensions, right, we would create a structure that would come out from the screen. So your array in position 1 would be a bunch of array positions, and they would just come out from the screen. That's the only way that you could visualize it, to see it. Can't really do that in Excel. Kind of mentally I can do it, sort of, right? All right, and that's a 3-dimensional array. So, interestingly, could I do more than 3 dimensions? Yes. How many could you do? As many as you can imagine. The problem is the conceptualization of it, right? So when I'm working with a 2-dimensional array, it's easy because I can look at it on a screen and say, okay, that's an array, that's a 2-dimensional array. All right, I guess I can kind of imagine that each one of these also has an array in it, but what if each one of those also has an array in it? Mind is blown, right? You're not even going there, right? Your visualizations are toast. You know what? There are people that program multi-dimensional arrays like that. You really have to have a conception. So for example, let's take the rent thing one step further. Floors and bedrooms, right? And then we threw in buildings. All right, so we got multiple buildings that have floors and bedrooms. What's the next notch up? Cities, right? How many cities? Okay, so I can start to conceptualize that kind of, right? So we have an apartment complex that's got 10 buildings. Each one of those has floors, each one has bedrooms. And now we're just adding another town, another apartment complex. Okay, so that's a 4-dimensional array. All right, and then where would you take it from there? Countries? Planets? Universes? I don't know. I mean, that's where it gets to. And what's fascinating about that is when you're talking about multiple dimensions like this, it's kind of interesting because, you know, when we think about our physical space that we exist in, it's kind of the same way. We can envision things in 2 dimensions real easily because 2 dimensions can appear in 3 because we exist in a 3-dimensional world. And we can visualize 3-dimensional objects because we can pick them up in our hand and rotate them and see how big they are and measure things in 3 dimensions. How do you measure the 4th dimension? Because there is a 4th dimension, right? We just can't visualize it in 3-dimensional space, right? So it gets very fascinating when you start to operate on that level, just conceptually. I think it's bizarre. But it says, as long as you can keep track of the order of the variables and needed subscripts, and as long as you don't exhaust your computer's memory, Java doesn't care how big you make your arrays and how many dimensions exist. So from a computer construct standpoint, the number of dimensions in an array is basically infinite, as long as your computer can handle it and your mind can deal with it. And functionally, I've rarely seen people go beyond 3, 4, 5 dimensions because they just cannot conceptualize the concept. They can't, you know. All right, let's go ahead and play with this one now. Let's try this one out. All All right, so we're going to create a new file in our editor. So let's just go ahead and I'm going to right-click here, create a new class file. I'm going to go steal the name. Of course, they always put it at the bottom. Two-dimensional array demo. Two-dimensional array demo. Not a very efficient name, but there it is. Create our public static void main. Get rid of the comments. All right, so we got that going already. Let's go ahead and start declaring a two-dimensional array. Right? So we're creating something with 3 rows, 3 columns. Pretty easy to visualize. Calling it count. We're going to throw in a scanner, some variables, and a constant. All right. Let's get our library in there. All right. Next thing that we're going to do is put in a prompt to the user. And I'm going to condense this down to 1 line. Doesn't seem logical to me for it to be on 2. Right? Enter a row or 99 to quit. So what's 99 going to be? It's going to be our sentinel value for popping out of a loop, is my guess, right? So enter a row, and then you grab the row number. So once we've typed in a row number, next thing we're going to do, assuming they didn't enter 99, right? Then we're going to ask them to enter a column. So they're going to enter a row number, then they're going to enter a column number. So we're letting them pick the position where the data is going to be inserted. That's what we're doing. All right? Then we start to ask, if the row is less than the count length, what's the count length? Where are we getting that from? Right, exactly. How big the array is, right? So, and the column is less than the row length, right? So we count the row length. Then we're going to go ahead and increment the row. Why would we do that? Because you are going to traverse that structure. I think it's interesting how they give you the code in pieces like this. And then am I putting everything in the right place? Yes. Oh yeah. Except I'm going to indent so it's easier for you guys to see. How much of this should be indented? What about this one? Yeah. All right. So I'm kind of testing you guys here to see if you guys are getting your nesting straight, because that can become kind of a significant issue. All right, so I'm checking all of my stuff here. I think I'm missing one, aren't I? That one's indented there. This one goes parallel with that. Yeah. See? Oh, I see. There's an else below. All right. Let's grab the else. Ah, so you see what they're doing is they're putting in a provision here just in case they put in row and column numbers that don't make sense. It says at the end of the loop, all right, so I look at this and I'm scratching my head a little bit. At the end of which loop? The answer is, of course, is already at the end of the while loop. So we would go here. So we're out of the else at this point. And once again, I'm going to clean this stuff up. Did I just get rid of a double quote? I sure did. Now let's see if we can get our curly brackets in the right spots. These are lined up, those are lined up. The else doesn't need one. This should probably come out here. And you see what they're doing is they've given me too much, right? And that should be correct. And I don't see any flags or warnings or anything, so I think I got my curlies okay. So if I take this and just kind of look at it as an overview, here's the whole while loop. All right. Let's give it a shot and see if we can build it. Now the beauty of this is you can see what the output is it shows you what you're doing as you're doing it. So I think this is kind of cool, right? So you could make this bigger or smaller if you want. So let's go ahead and do that. Let's save the code. Let's get that console area kind of up so we can see it. And let's hit play. Enter a row or 99 to quit. You know what? I'm going to try the 99 thing. See if it. Well, I guess it quit. Okay. I might put in a little message that says, thanks, bye. That's me. Right. All right, let's try it again. Enter a row or 99 to quit. So I'm going to put in row 0, enter a column 0. All right. Is that what you expected to see? So all it's doing is putting a 1 any spot that we've selected. What if I type in that's kind of interesting because it waits for you to enter both before it tells you that. It's not telling you which one is invalid. So if I were to ramp up a program like this, I would put in something that would say that's not valid, like right when you're entering it, but then that's a separate check. But it is figuring it out that it's not valid. And at this point, I'll do a couple more. Which seems to be working fine, right? So let's just put in our 99 to quit, and then call it a day. All right, let's proceed. Now that we've completed that, you do it, let's move on to the next topic here, which is using the array class. So because arrays are a type of object inside of Java, that also means that typically, because they are a class that you can instantiate, they typically have a lot of methods attached to them to help you manipulate, sort, arrange, et cetera, with arrays. And that's kind of an important thing to know. So here's kind of an interesting thing, right? We worked on learning what a bubble sort is and an insertion sort. And then you get into the array class and you start figuring out that, oh, wait a second, there's already a sort? Why are we writing one from scratch? Right, and that's the kind of thing that you do. So the truth is, with all of the major types of sort algorithms, as students, you'll always be forced to learn kind of how they function. It's kind of like learning how like a engine functions if you're an auto mechanic. And then you realize that sometimes you can go in there and you can fix the engine, and sometimes you don't touch it, you just let it do what it does, right? And in this case, they already have a sort algorithm that's attached to the array class. So if you do want to sort something, you can actually just issue the command to sort an array, and it will do it for you. And notice that it not only allows you to sort the array, but it also allows you to declare starting and ending point of what you're sorting. So that can be really handy as well. They have other little things. So like one thing that you can do, especially if you get arrays that get really large, is there's a search built in. Isn't that interesting? Now, why would something like that be helpful? Well, believe it or not, you know, a lot of our programs that we use, so I'm going to go back to Excel, for example. When you start to think of this concept of array structures, right, and you start to recognize that really a tool like Excel is really a two-dimensional array tool, and heck, if you start adding more worksheets, well, there's your third dimension, in a sense, right? But that whole construct of how Excel operates as a program is completely predicated upon the fact that it is working with arrays. I think that's mind-boggling, really, right? Because we have all these little containers where we can put stuff in. Everything's already enumerated, so our columns are letters and our rows are numbers. Isn't that interesting? So really, how did they create Excel as a program? They created this interface that allows you to type into any cell, and then all it does is when you type into that cell and you tab or move to the next field, is it's just storing it in an array position relative to that spreadsheet, a two-dimensional array. Whenever you're performing a formula or a sort or a search or any of that stuff, they're all extrapolations of that simple construct. And I think that's just so fascinating because the people that just even figured this out as a data structure, right? You know, spreadsheets have been around since the 70s. Maybe, you know, for as far as I know, maybe even earlier than that. You can look it up. But I remember programs like Lotus 123 and VisiCalc and, you know, stuff like that that we were using way back in the day, and didn't really give a lot of thought as to how people actually created those array structures, but they use those array structures to create programs like. All right, so a lot of these little extra methods that you get with your arrays can be kind of useful and really shortcuts, and these are not the only methods that are available, but those are some of the common ones. So how would you apply some of those things? They just give you some really quick examples here. So if you had some arrays that had values in them and you want them sorted, you can just simply call the arrays method that's built into the Java utility class, and it will feed the array into it, and then you pass whatever parameters are required, and it will go ahead and sort it for you. You don't have to write the sort. Yay! Right. Which then begs the question, why did they even tell us about sorts to begin with? You know, so I have this like weird thought about like how that is written in the book, but you know, that's just me. All right, so that's just an example of how to go ahead and sort. All right. What I'm going to do next here is kind of take you to this little tidbit here, which shows you how to do the binary search. So if you're searching for certain values in an array, and frankly, I think that's more useful with strings than it is with numbers, but it can work with numbers too. This is a little example of how you do something like that. So if you compare that to what you're doing in a database, or what you're doing in a spreadsheet, or heck, in a document, right? You got to remember that whenever we're dealing with characters on a computer screen, and whenever you're stringing those characters together, and this is what's fascinating about Java in my mind, is you notice how string is actually a class, right? It starts with a capital S, that indicates it's a class. a string is always an array of characters. So isn't a paragraph also an array of characters? Isn't a whole document an array of characters? You see where I'm going with that, right? So whenever you pull up like a browser or a document or a spreadsheet and you do Control F to find something, what are you really doing? You're triggering something very much like this. Some built-in search algorithm that's already embedded into the infrastructure, and you're just typing in a search parameter and it's finding it on the fly. I think that's just awesome. So whenever you do that in any program, I can do it right here inside my PDF thing, and I can type in a search and it'll find it. I'm not going to do that because I don't want to lose my page, but you guys should be aware that most programs have that built in. And that's all they're really doing is triggering that sort of a thing. Now, I'm looking at the clock here, and I think we might have enough time to finish this one last example. So we're not going to actually, I think, make it to doing exercises. Sorry, Christian. You guys will have to do those exercises on your own. But let's try this little tidbit here. All right, so we're going to create another new program. So let's do that. So I'm just going to create a 9 new class file. Once again, I'm going to race ahead and steal the name. Menu search. All right, and let's see if we can get this built out pretty quickly. Get rid of that comment. I'm going to try to shortcut things as much as I can to make it efficient. So I'm just going to grab the libraries right away and drop them in. So we're declaring a few variables here. Some are string, an array of strings, menu choices, apparently 10 of them. An entry field and a menu string, both are initialized, to a null value, not nothing, but null. And then we're going to issue this little command here. What's that going to do? It's going to fill the whole thing with Z's. So every menu choice will be all Z's. We're going to throw in this little bit of code here. And I guess that line makes sense to have it back like that, but this doesn't. So I always like to clean things up like this because in my mind it just makes it easier to see and read. And maybe you guys don't agree, but all right, this is all one statement, by the way, right? Just wouldn't fit on one line. And this is going to come back to here. It's always fun to try these little examples. And I don't know if you guys pick up on this or not as you're working through this book, but one of the reasons you do the example problems in this book, why, a Christian might not assign them, but I do, is because some of them are sometimes the clue to doing the homework. So it helps you a lot. The code's given, so you can't really screw it up. So if you're not in the habit of doing them, you might want to change that mindset. And I'm sorry I'm kind of abbreviating and not explaining as much now, but let's just get this code in here and see if we can get it to work. We just got a mere few minutes left in class. And this is all indented, right? And according to that, we should be all complete with everything we need to do. So the goal of this now is to, you know what? I'm not even going to talk about, let's just do it. All right, let's just do it and see how it goes. This is going to bring up little dialogues. Enter an item for today's menu. I don't know. salad, soup, sandwich, fries, Coke, coffee, cookies. I'm trying to cover the whole gambit here, right? Mashed potatoes. I can even spell it. Or is these easy to quit? I'm out of there. All right. All right, pretty simple little interface, right? So now it says, please make a selection. I'm going to have coffee all day long, so I may as well select that. Excellent choice. It is an excellent choice. Thank you. Thank you very much. And if you typed in something that's not on the menu, it would not appear. So how is it doing that? It's going through and it's looking through what you just entered. So this is a way to enter stuff into a structure, search that structure based upon what somebody's typing in. It's not really that difficult to code. It's quite a number of lines there, but most of them are interface lines rather than logic lines. What really makes all of it work.
Does it need to be sorted for finance?
Does it need to be sorted? No.
Okay, they're sorting it out.
Yeah, it doesn't need to be. That's actually a good question, Brenda. Because how are they searching, right? So what they're doing is basically they're looking at each position and saying, does it match this? Does it match this? Does it match this? The other thing we didn't try is like if I spell coffee with a lowercase c and then an uppercase c, would it work? I guess we didn't try that. I can tell from the code what the answer is, right? The answer to that is no. But it's kind of an interesting thought. So the reason that you ask, right, and this is really kind of an interesting question, how do you make your searches faster if they're sorted, right? So think about this. In the old days when we used to go to the library, and this is a great example, you walk into a library, and when you look at a book on the shelf in the library, and you look at, on the spine, they put, okay, there's the author and the title, that's printed on the book, but then they usually put a little thing on there, right? And it might be the Dewey Decimal number or whatever library code they use, right, for putting the books on the shelves. And whatever method they use to organize books, who knows, right? Usually you like to think all the computer books are on one shelf, and all the books about travel are on one shelf, something like that. But when you go to the card catalog in the library, in the old days, mind you, right, you would walk in and they would have 3 sets of index cards in the old days, right? You know where I'm going with this? So the first one was author, I think, subject, and title. So they had indexes, and these are really kind of important things, indexes based on each one. So the one index would have authors sorted by last name. The other one would be subjects sorted by alphabetical, right? And then titles. And so each one of those is basically a pre-sorted list to help you accelerate your search. Because in the old days, if you weren't using a computer and you knew what title, I'm looking for War and Peace. I'm going to go to W and start, W-A, there it is, okay? And I would find it. And the only reason I could find it is because it's because the title is alphabetical. I don't remember who the author is, right? I don't remember what the subject is. I don't know, Russian history? Russian drama? That's the kind of thing. So that's, a technique. And you know what? It is the type of technique that Google uses, for example, when you go to a search window and you start typing in something that you're searching for. And I always find it fascinating with search services like that, how many of them are in tune to not only what their database of pre-sorted items is, but also the stuff that you're either looking at, talking about, searching for in the past. So like if I want to learn about just for example here, if I even have a browser open, like last night I was going to watch The Walking Dead, so I just started typing basically The Watchmen came up, whatever. Apparently that's more popular than The Walking Dead right now. But so now goes The Walking Dead. But sometimes it floors me how quickly it pulls up like the stuff that I'm searching for just on a couple letters. So that's kind of an interesting thing. The way that it does it, obviously, is not just, pulling stuff up alphabetically from whatever list they have, but based upon what your search history is, what your interests are, et cetera, et cetera. But that is like using multiple indexes, and I think that's really kind of an interesting example. We are, in essence, out of time here, folks. The part that I didn't get to that you guys should make sure that you read up on is array lists. I know that Christian's going to want you to know about this, but an array list is very similar to an array, but if you notice, they are not using a square bracketed thing here. This is actually a class, and you can create it very similarly to an array. The difference is because it's an array list, it allows us to do a bunch of different types of actions to it because it's now a class rather than a data type. So please make sure that you read up on that section. There's some syntax things that kind of go with it, which I'll let you figure out on your own, but that's kind of like the basic approach there. So take some time to read this. If I had more time in class, I would go through it, but we are out of time. All right. Thank you, guys. We'll see you in my class, I guess, whatever that is.